Hi everyone. Okay, let's start going over the assigned exercises for Chapter 6, Part 5, which has to do with break even. Okay, so Toys for You manufactures toys and it sells each of them for $30. Okay, so $30 would be the selling price. The variable cost per toy is $10 and the fixed cost for this line is 100,000 per year. And they estimate that they can produce 8,000 toys per production period. So that's would be their full capacity. So what is the break-even point in units? So break-even is when your net income is zero. Okay. So you've got your selling price minus your variable cost, which is 30 minus 10 multiplied by x, and the x is what we're trying to figure out. And then we're going to subtract off the fixed cost of 100,000. So we're going to manipulate that equation so that we have x by itself. So we've moved the 100,000 to the other side, and then we move the 30 minus 10 to the other side, and that gives us x equals 100,000 divided by 20. So therefore, the break even in units is 5,000 units. And one way you can make sure is put it back in the equation. Okay, so where it says 30 minus 10x, put the 5,000 in there and make sure that it does work out. So 30 minus 10, is 20. 20 times 5,000 is 100,000. Minus 100,000 gives you 0. So we know it's correct. B, what is the break-even sales revenue? So if we know that the break-even in unit is 5,000, and we know that we sell each one for $30, 5,000 multiplied by $30 selling price each gives us 150,000 sales revenue, and that will break even. C, what is the break-even volume as a percentage of capacity? So we know we produced 5,000. We know we can produce 8,000, and 8,000 represents 100% capacity. So 5,000 units divided by 8,000 units gives us 62.5% of capacity. Okay, so D, what would their net income be if they sold 6,200 toys? So if we have a look here, 6,200 units multiplied by the selling price of $30 gives us sales revenue of $186,000. Okay, then we want to do our variable cost. So again, we've got our 6,200 units. We know it's a $10 variable cost, so that's a variable cost of 62,000. We know fixed costs are 100,000, so we've got sales revenue minus our variable cost minus our fixed costs leaves us with 24,000 net income. Okay, so E, what level of output is required to have a net income of 10,000? So it's the same equation, except the only thing is it's not going to be equal to 0. So if you look here in A, to break even, net income was 0. So therefore it would be 0 equals your selling price minus your variable cost multiplied by X minus your fixed costs. Okay, so again, we don't want it to be 0. We want it to be 10,000. So again, it's the same formula. So 10,000 equals 30 minus 10 multiplied by x minus 100,000. So we're going to move the 100,000 to the other side and then divide it by the 30 minus 10. So that would leave us with x equals 110,000 divided by 20 gives us 5,500 units, and that's how many units we'd have to sell, or how many toys we'd have to sell if we want a net income of 10,000. Okay, so let's sell some jam. Question number 3. So again, the best thing to do when you're going through is look at the information you have and write down what it is. Okay, so we know our fixed costs are $2.50 per month. Okay, watch that, per month. We've got a variable cost per jar of $1.20, and it sells in the grocery stores for $3.20 each. How many jars must she sell per year to break even? Okay, so we know her fixed costs per month, multiply that by 12, and then we have fixed costs of $3,000 per year. So now to break even, we need our total revenue to equal our total costs. So therefore we have our 320x equals 120x plus 3,000. So again, you move the 120 to the other side. That leaves us $2x equals 3,000. Then move the $2, divide each side by the $2. X equals 3,000 divided by 2 equals 1,500 jars of jam. Okay. But again, you can do different formulas, right? To break even, total revenue equals total cost. But up here, we used a different formula. Okay, so break even or net income of 0 equals selling minus variable multiplied by X minus fixed cost. It's the same thing. It's just a different format of the formula, but it's the exact same thing, okay? So for B, sorry, I'm going to back up for a second. So therefore, if you used this formula, the total revenue equals total cost, or if you use this formula, selling minus variable, multiply that by X minus fixed cost equals 0. Either one, in either spot, if you use the same formula for both, if you used opposite ones, it's okay. It's the same end result because it's just the same information in a different format. Okay, so B, what will her profit be if she sells 3,000 jars per year? So we've got total revenue, 320 multiplied by 3,000 jars gives you 9,600. We've got variable costs, $1.20 per jar multiplied by 3,000 jars to give you 3,600. We've got fixed costs of $3. So therefore we've got our total revenue minus our variable cost minus our fixed cost gives you 3,000 per year. How many jars must she sell per year to have a loss of no more than 1,200? So here I'm using this formula. So we know the net income. She wants no more than a loss of 1,200. So we've got a net income of negative 1,200 equals our selling price minus our fixed cost. Multiply that by the number that we're looking for, which is our X minus 3,000. So again, change the equation around, get rid of the 3,000 on each side. So then we've got 3,000 minus 1,200 equals 2x. That gives us 1,800 divided by 2 means 900 jars per year. All right, now let's sell some CDs. Okay. So CD Solutions Limited manufactures and replicates CDs for software and music recording companies. CD Solutions sells each disc for $2.50, so there's our selling price, and a variable cost per disc of $1. Just to break even, how many CDs must be sold per month if the fixed cost is $60,000 per month? Okay. So again, we've got our total revenue, we've got our total cost formula, and we know that to figure out our break even, our total revenue must equal our total cost. So therefore we've got 250x, which is our selling price multiplied by x, that's our total revenue, and that equals $1x, which is our total cost, that's our variable, plus 60,000. Okay, so we're going to move the 1x, or get rid of the 1x on this side, so therefore we have to subtract an x from each side. That leaves us 1.50x equals 60,000. X equals 60,000 divided by 150 gives us 40,000 discs per month. What must sales be in order to have a profit of $7,500 per month? Okay, so again, we're going to use our net income equals selling minus variable, multiply that by x, minus our fixed cost. And we know our net income is $7,500. So we're going to solve our equation. We want to get rid of the negative 60,000 on this side, so we're going to add it to the other side. That gives us 67,500 equals 150x. So 250 minus 1 gives us 150x. So therefore we have 67,500 divided by 150 equals our x, because we have to get rid of that 150 to have the x alone. So we divide both sides by 1.50, and therefore x is 45,000 discs per month. C, what will their profit be if they have total revenue of 130,000 per month? Okay, so if we have 130,000 per month, we know we sold each of those discs for $2.50. That means we must have sold 52,000 CDs. Okay, so how much is our total cost related to the sale of those 52,000 CDs? We know that there's a variable cost of $1. Multiply that by the 52,000 CDs plus the 60,000 fixed cost, which doesn't change, gives us a total cost of 112,000. And we know that total revenue minus total cost gives us our net income. So therefore our net income per month must be $18,000. Final question, D. How many CDs would have to be sold per month to break even if they increase their selling price to $3.50? Okay, so it's the same as A, okay, total revenue equals total cost, except now our total revenue is $3.50. So 350x equals $1x, our variable costs associated with each CD, plus the 60,000 fixed cost. We're going to move this 1x, get rid of it from each side. That leaves us 250x equals 60,000. Therefore, x equals 60,000 divided by 250 gives us 24,000 CDs per month. Okay, let me know if you have any questions at all, and I will give you a hand. Thanks, everyone.